The chapter's name is Sound. Chapter 13th of Class 8th. The main contents of this chapter are: first, sound is produced by a vibrating body. Second, sound produced by humans. Third, sound needs a medium for propagation. Fourth, we hear sound through our ears. Fifth, amplitude, time period and frequency of a vibration. Sixth, audible and inaudible sound. Seventh, music and noise. Eighth, noise pollution. How will you know when there is someone outside our house? By hearing the knock at the door or by the sound of the doorbell. We will know that there is someone outside our house. We can hear a variety of sounds from different musical instruments like guitar, violin, then keyboard, etc. We enjoy the sweet sound of music bells. In hide and seek game, the blindfolded person can tell who is close to him by hearing the sound. So, in all the above cases, where someone is knocking at the door, then about the musical instruments, the sound of the musical instruments, then in the hide and seek game, the blindfolded person recognizes the person by their sound. In all these cases, sound plays an important role in our life. Have you ever thought how sound is produced? We are all familiar with sound. We are always hearing sounds of different sources in everyday life, in every second. Have you ever thought of how this sound is produced? Let us look how sound is produced. For that, we are considering some examples. You all know about the school bell. Touch the school bell with your fingers. Can you feel any vibration? Certainly not, isn't it? It is still. There is no vibration for the school bell as it hangs. If we strike the bell with a hammer and then touch it with your fingers, then you can feel the vibration as well as you can hear the sound. Then what you have to do is hold the bell with your hand while there is vibrations. You can see that vibrations subside. Along with that, the sound also subsides. That is, you can notice that when we strike the bell with a hammer, then vibrations are formed and we can hear the sound. Then if we hold the bell with our hand, the vibrations slowly subsides, and along with that, sound also subsides. What can you infer from this? Let us look into another example. Put a rubber band along the long side of a pencil box. Insert two pencils between the box and the rubber band. Plug the band in the middle. We can see the band vibrating and producing a sound. In both the cases, we have seen vibrations are formed when a body is struck. What is meant by vibration? What do you understand by the term vibration? The to and fro or back and forth motion of an object is termed as vibrations. In the former cases, we have seen the definition for vibration. But how will you see the vibrations? For that, we are doing an experiment. Take a metal dish filled with water. Strike it with a spoon. We can hear sound as well as we can see waves on the surface of water as the plate is vibrating. When we strike the metal dish with a spoon, vibrations are formed on the plate, and these vibrations are transferred to the water and we can see the vibrations on the water surface. Then if we hold the dish, the vibrations come to a stop. As the vibrations come to a stop, the sound also stops. From the three experiments, we can see that there is some connection between vibrations of a body and sound. That is, vibrating objects produce sound. In some cases, vibrations are visible to us. In most cases, their amplitude is so small that we cannot see them. However, we can feel them. We have seen that vibrating parts make sound. So here are some musical instruments. Identify the vibrating parts of these instruments. We can see that the vibrating parts of these musical instruments make sound. This is a picture of veena. The strings in veena vibrate to produce sound. Here we can see the strings of veena, and the vibrations of these strings produces sound. This is a picture of tabla. The membranes here. The membranes of the tabla vibrate when we strike it, and the membranes of the tabla vibrate and it passes on to the air inside it, and there will be vibrations of the air also, and it produces sound. This is the picture of flute. This is the hole, and when we blow air through this hole, the air inside the flute will vibrate, and this vibration of air produces sound. This is the picture of ektara. Here also the strings of the ektara vibrates to produce sound. This is the picture of mridangam. It is similar to tabla. When we strike mridangam, the membrane as well as the whole body and air inside it of the air inside the instrument vibrates, and this produces sound. So, in all the instruments, the sound is produced by the vibrations of not only a particular part but also due to the whole body of the instrument. Let us see another musical instrument which can be made out of some glasses and water. Take 4 or 5 glasses, fill the glasses with water up to different levels. Strike the glasses gently with a spoon or pencil in succession. We can hear a pleasant voice. This is Jal Tarang. We have seen how sound is produced in various surfaces and in various musical instruments. Let us see how sound is produced in humans. How sound is produced in humans. For that, you just speak loudly and place your hand or fingers on the throat. You can feel the vibrations on your throat while you speak. So in humans, the sound is produced by the voice box or larynx. Okay, we have seen that the voice in human beings is produced by the vibration of the voice box or larynx. What is larynx or voice box? The part of the throat that seems to move when we swallow is the voice box. We can feel it. There is a part of the throat that seems to move when we swallow food. That is called voice box. It is at the upper end of the windpipe. 2 vocal cords are stretched across the voice box in such a way that it leaves a narrow slit between them for the passage of air. So the vocal cords, here we can see 2 vocal cords are stretched across the voice box, and there is a narrow slit in between them for the passage of air. When we speak, air passes through this passage and the vibrations causes the sound, produces the sound. Let us see how sound is produced. When the lungs force air through the slit, the vocal cords vibrate producing sound. Muscles attached to the vocal cords can make the cords tight or loose. When the vocal cords are tight and thin, the type or quality of voice is different from that when they are loose and thick. We can demonstrate the functioning of vocal cords using two rubber strips. For that, take two rubber strips of same size. Place them one above the other. Stress them tight. Now blow air through the gap between them. As the air blows through it, a sound is produced. This is also a demonstration using a piece of paper. Fold the paper as in figure. Make a hole as in the picture. Blow air through the gap. A sound is produced. This is very similar to the functioning of vocal cords. There is a small gap between the paper strip as in the case of vocal cords, and when the lungs force the air through the vocal cord, sound is produced by the passage of air and vibrations of air. Similarly, when we blow air through the gap, the vibrations of the air and as well as the vibrations of the paper as a whole makes sound. The vocal cords of men is about 20 mm long, whereas for women the vocal cord is 5 mm shorter than men. For children the vocal cord is very short. That's why all the three has got different voices. Sound needs a medium for propagation. To prove that a sound needs medium for propagation, we are going to do a simple experiment. For that, first of all, place a cell phone in a glass which is very dry. Then ask your friend to give a ring to this cell phone. Then close the rim of the glass with your hand or plate and ask your friend to give a ring. In that case also, you can hear the ring of the cell phone. Then, meanwhile, with your mouth, slowly suck the air in the glass. Remember, the glass is covered by your hand or with your hand or by a plate. Then, slowly suck the air in the glass. As the air is removed, you can see that the sound of phone gradually becomes feeble. When there is complete vacuum in the glass, you cannot hear anything. From this experiment, we can see that sound cannot travel through vacuum. Also, sound requires a medium for propagation. When the air in the glass is completely sucked, then we cannot hear any sound, means there is no medium for propagation of the sound. It is complete vacuum, and as the sound cannot travel through vacuum, we cannot hear the sound. So, for the sound to propagate, it requires a medium. Let us do another experiment. Take a bucket of water. Try to ring a bell inside water without touching the sides or bottom of the bucket. Keep your ear near to the water level. Can you hear the sound of the bell? Yes, isn't it? This shows that sound can travel through liquids. In the first experiment, we have seen that the sound travels through air and it requires a medium for propagation. In the second experiment, the bell is inside the water and the sound produced by the bell, we can hear the sound, means the sound can travel through water also. That is, sound can travel through liquids. Let us consider another experiment. Take a long meter scale. Hold its one end. Place your ear at that end. Then ask your friend to scratch the other end softly. Can you hear the sound? Yes, you can hear the sound. So, this shows that sound can travel through solids also. Because if the friend scratches the other end of the scale, you can very softly you can hear the sound at the other end, means that the sound travels through the scale, or it can travel through solids. In the case of toy telephone, sounds are produced by the vibration of strings. Toy telephone is made using two cups. It is connected with a string. When we speak through one cup, the vibrations will be transferred to the other cup, and we can hear the sound through the other cup. In all these cases, it is observed that vibrating objects produces sound, and this sound is carried in all directions in a medium. How can we hear sound? This picture is the picture of section of ear. The outer part of the ear is this, and there is an ear canal, and at the end of the ear canal there is a membrane which is stretched like a rubber sheet. When sound is produced, the air will get into this air canal, and the vibrations of the air makes the membrane or eardrum, this is the eardrum, and makes the eardrum vibrate. This membrane will vibrate, and the vibrations are transferred to the inner ear. From that inner ear, the vibrations, that is signals, goes to the brain, and we can hear the sound. This is the closer picture of eardrum. The eardrum vibrates, and through these small bones, the vibrations are transferred to the inner ear, and the signals are sent to the brain through nerves. How can we hear the sound? It is explained here. The thin membrane at the end of the ear canal, which is stretched tightly like a rubber sheet, is called eardrum. When sound enters the ear, it makes the eardrum vibrate. The eardrum sends vibrations to the inner ear. From the signal goes to the brain. That is how we hear. This is a simple demonstration for the working of eardrum. Tin can model. For that, take a small tin can. Cut its two ends. This is a tin can. Cut its two ends. Then stretch a piece of balloon over its one end. Fasten the balloon using a rubber band. Then put some food grains over it. Then speak through the other end. While we speak, the air will get into the can and the air vibrate, and this makes the membrane or balloon vibrate. And as the balloon vibrate, we can see the grains over the membrane jump up and down as we speak. The vibrations due to the sound makes the stretched balloon vibrate. This in turn vibrates the food grains. This is very similar to the functioning of eardrum. Next topic is amplitude, frequency and time period of a vibration. We know that to and fro motion of an object is called vibration. It is otherwise known as oscillatory motion because the object oscillates between two positions. So it is the to and fro motion of an object. One to and fro motion constitutes one oscillation. Number of oscillations in 1 second is called frequency of oscillation. Its unit is hertz and the symbol is Hz. A frequency of 1 hertz means 1 oscillation per second. So if frequency of 20 hertz means 20 oscillations or 20 vibrations per second. Let us look into a simple experiment. Take a metallic tumbler. Strike its sides gently with a tablespoon. Suspend a small thermocol ball touching the rim of the tumbler. Observe how far the ball is displaced when we strike the metallic tumbler with a spoon. This displacement of the thermocol ball gives the measure of amplitude of vibration of the tumbler. Then strike the tumbler strongly. Again suspend the thermocol ball. Measure the amplitude of vibration. Then compare the two. We can see that displacement is greater when the tumbler is striken with a strong force. As amplitude increases, sound also increases. Loudness of sound is proportional to square of the amplitude of vibration producing the sound. Its unit is decibel. Normal breathing sound is 10 decibel. Above 80 decibel, noise becomes painful. Normal conversation is about 60 decibel. So, the loudness of sound is proportional to square of the amplitude of vibration producing sound, means that when the amplitude of vibration is large, sound produced is loud. When the amplitude of vibration is small, the sound produced will be feeble. If two sounds are equally loud, then we can differentiate the sounds by frequency, shrillness or pitch of the sound. Frequency determines the shrillness or pitch of a sound. Frequency greater means the sound is shrill and has higher pitch. Frequency is greater means sound is shrill and has higher pitch. Drum vibrates with low frequency, so it has low pitched sound, whereas whistle vibrates with higher frequency, so it has high pitch. We can see here the frequency of vibration is low, that is number of vibrations per second is low. Here in the case of whistle, the number of vibrations per second is more, that is it has high frequency whereas it has low frequency. High frequency means it has high pitch, low frequency means it has low pitch. You all have heard the sounds of birds, chirping of sounds. The birds make high pitched sound. The lion makes low pitched sound compared to the birds. But the roar of lion is louder compared to the chirping of birds. Chirping of birds is feeble when compared to the roar of lion. You all know that the lion roars louder. Similarly, the frequency of voice of children is higher compared to adults. The voice of women has higher frequency and is shriller than that of men. Next topic is audible and inaudible sounds. You know that all vibrating bodies make sound, but human ear cannot detect all sounds of vibrating bodies. Sounds of frequencies less than 20 Hz cannot be heard by human ear. Such sounds are called inaudible sounds. Sounds of frequencies greater than 20 kHz is also not audible to us. So, the range of frequencies that are audible to human ear varies from 20 to 20,000 Hz. 20,000 Hz means 20 kHz. The range of frequencies that are audible to human ear varies from 20 to 20,000 Hz. So, we can see that in between 20 to 20,000 Hz, it is the audible range. The sounds which comes between this range is called audible sounds. Whereas, sounds that has frequencies less than 20 Hz and greater than 20,000 Hz are not audible to us, so it is called inaudible sounds. Though human ears cannot hear the frequencies greater than 20 kHz, some animals can hear frequencies greater than 20 kHz. Dogs can hear frequencies greater than 20,000 Hz. So, the police uses whistles of high frequencies which dogs can hear but humans cannot. Then, many ultrasound equipments for medical investigation and tracking uses frequencies greater than 20,000 Hz. Comparison of different sounds. Let us compare different types of sounds. First, sounds of vehicles, sounds of children talking together in classrooms, sounds of horns of different vehicles on the road, sounds of construction site. These sounds are not at all pleasant, or these are not pleasing sounds. Whereas sounds of musical instruments, sounds of songs, then sounds of soft breeze, sounds of chirping of birds, these are all very pleasing to our ears. Such sounds which are not pleasing to our ear, that is, the unpleasant sounds, are called noise. The sounds which are so pleasing to our ears is called musical sound. Noise pollution. What is noise pollution? Presence of excessive or unwanted noise in the environment is called noise pollution. Sounds of vehicles, explosions, loudspeakers, crackers, television and radio in high volume all contribute to noise pollution. Noise pollution has its harmful effects also. Noise pollution results in various health problems like lack of sleep, hypertension, anxiety, permanent hearing impairment, etc. There are various health disorders caused by noise pollution. See the pictures of sounds, various sounds coming from different sources. Train, loudspeakers, aeroplanes, TV, computer, radio, mixie, grinder, then machines from industries, then car, scooter, buses, all these contribute to noise pollution. How can we limit noise pollution? We should control noise pollution because it is very harmful to us. By using silencing engines in vehicles, machines, etc., we can reduce noise pollution. By minimizing automobile horns, by lowering volumes of television and radio, by conducting functions using loudspeakers away from residential area, we can limit noise pollution. Also by growing trees, because trees cuts off sound to a certain extent. And that is the end of this chapter, and we will be back with another chapter.